Warm welcome everyone. This is Diksha Kulkarni, and today I am going to give a presentation about the major project that me and my friends I have made. Uh, and the title of our major project that we have made is Detection of Objects by Sight for Autonomous Vehicles Using Deep Learning. And the abstract of our project goes like object detection is also one of the critical components to support autonomous driving. The autonomous vehicles rely on perception of their surroundings to ensure safe and robust driving performance. Uh, Deep learning based object detectors play play a major role in finding and localizing these objects in real time. As we know, the 2D object detection, it has achieved a remarkable success, but when compared to that of 3D detection, 3D detection has received more remarkable adoption when compared to that of 2D. So now 3D is more preferred when compared to that of 2D. And the existing system of the object detection in autonomous vehicles is it has low resolution and high false positive rate, which results in inaccurate detection and classification of objects on the road. These systems use computer vision algorithms to process the data collected by the sensors and identify objects such as other vehicles, pedestrians and obstacles. Whereas the proposed system that I and my friends have worked on, and we have made a change in this project that the fault we have made a change in the project that uh, we have made a model such that it will have a high resolution and low false positive rate, which will result in more accurate detection and classification of objects on the road. Our system utilizes deep learning algorithms to accurately detect and classify objects in real time, which will allow to give more precise results when compared to that of existing system. And not only that, we have trained our algorithms on various datasets also, due to which we'll get more precise results, and will get fast results also. Our system processes data in real time, allowing for immediate detection and response to potential hazards on the road. It ensures the safety of the pedestrians and passengers that will be moving on the road. So the system analysis of our project is this whole project, like the detection of objects by sight in autonomous vehicles, it involves breaking down the entire process into its key components. So what do we mean by this is we have many key components, and the key components that we have in our project is nothing but camera data, lidar data, radar data, and we have other few. I'll be letting you know about that also. So now first let's get into what do we mean by camera data. Camera data is nothing but it will give raw visual data captured by the cameras, and the cameras will be mounted on the vehicle. What do you mean by lidar data is it will give it is a cloud data. It will provide information about the environment's ecosystem and it will environment's geometry. Whereas radar data is nothing but it will give us the information about distance and speed of objects detected by radar sensors. And the other key components that we have in our project are lidar and lidar processing, object tracking, object classification, and image processing. So let's know what do we mean by what object tracking. It is nothing but it will implement tracking algorithms to monitor the movement of detected objects over time, which will ensure in smooth and continuous tracking for predicting future positions. What do you mean by object classification is it will classify detected objects into categories, like if there are any pedestrians, if there are any cyclists, if there are any vehicles present on the road, it will classify all the objects by using deep learning models which are trained on labeled datasets. Image processing is nothing but it will convert raw camera data into usable information, which will include object recognition, feature extraction, and segmentation. And the next part of our project is the system design. The design of our project is in a way that we have a driving environment, we have actuators, we have V2V, we have sensors, perception, planning, and control. So depending upon the driving environment, the sensors will work. We have different types of sensors like camera, radar, lidar, GPS, and others. The cameras will nothing but cameras. Let's get into a sensor called camera. So what camera does is it will detect if there are any lanes, it will detect if there are any traffic lights, and depending upon this it will perceive all of this, it will detect, and after detecting all of this it will make a plan on how to work of the thing that the camera has captured. It will make a proper plan, and depending upon the plan it will control the vehicle. Like if there is a vehicle moving in front of a vehicle, depending upon the speed and depending upon the distance, our vehicle will decide that when to stop and when to reduce the speed. So this is how our system, our vehicle is going to work. And the activity diagram of our system is nothing but when the user starts the engine, first it will check that if the autonomous mode is activated or not. If in case the autonomous vehicle mode is not activated, it will wait for the user